Greetings, class. This is Mrs. McCoy, and this is our lesson for Test 4, Section 5, where we are looking at quadratic equations and functions. And in this lesson, we're going to be reviewing our square root property, extending our square root property, and then developing the concept of completing the square. There is a pre-notes lesson that is helpful to have watched prior to the second page of this lesson, where I spend some time talking about the development of the perfect square trinomial that has a lead coefficient of 1. That will make this lesson easier to do. So our principle of square roots, as this book calls it, I call it the square root property, says for any real number k that if we can rewrite it as x squared equal to that number, then one of three things is going to happen. If it's a positive number, then we can have two roots, the positive root and the negative root, and we can write that as the two separate values. Sorry, I got to pull up the pen. We can write that as two separate values, and we can also write it as the two values combined using the plus minus key. If the value for k is 0, since 0 is neither positive nor negative, then we have only the one solution. And if k is less than 0 or a negative value, we're still going to have the principal root and the negative root, but we're also going to have a negative number under the radical, which says then we're going to have those two non-real complex or two imaginary solutions. And when we write that, the difference is that we're going to have an I as part of that solution. And of course, we have to remember that the square root of negative 1 is equal to I. So we would end up rewriting that product as negative 1 times now a positive number. And my pen stopped triggering there. And since we know we can split it up that way, that square root of the negative 1 is where the I comes from, and then we're able to work with that positive number as we always do. Now, as you recall, my math lab does allow you to use the plus minus when an answer can be combined into one, and that's anytime there's a radical or there's an I in the answer. If it does come out to be an integer answer or a fraction answer, we would expect to see the two separate answers. So, and of course, anytime you have the two separate answers, you do need to separate them by a comma. Now, our square root property says that we want to isolate the quantity square. Try that again. And again. There we go. We want to isolate the quantity squared on one side and the constant on the other. And I'm really emphasizing that quantity, and I'll show you in a couple different places why I'm emphasizing that phrase. And I'll also later point out where people who aren't being clear on their steps will confuse and do something totally wrong. So we want to be sure that we're really looking in terms of how these steps get applied. Now, in particular, step 2 is one that I require. So this is specifically what I am looking for. Whenever you look at help me solve this, they don't demonstrate this step in the way that I am asking for. So you have to make sure you're following your notes. So whenever we have that x or that quantity square equal to a number, our next step is twofold. I want to see that you take the square root of both sides, and on the side with the constant, we put in that plus minus symbol. So I want those two things in that step. So very specifically, you want to make sure that you're demonstrating step 2 fully. Once we've completed that step, we're going to do whatever it takes to simplify. And for our first couple of examples, our first two examples, we're just going to have once we've isolated that quantity square, then we're not going to have any other steps to do. But when we would look in question 2 at the alternate way to work it and problem 3, then we will see where we have those simplifying steps for step 3. Now, when you move on to classes beyond this one, upper level, those of you who are taking let me think, not trig, but pre-calculus. You're going to be able to skip step 2 and go right to the what it looks like with the application. Remember, in this class, this is where I am introducing or reintroducing concept and teaching it, and I want to see it fully worked out. So, when I ask for an exact answer, if we end up with a radical that can't be simplified, that should be in our answer. When we have an imaginary solution, that I will be in our solution. And it's only if I ask you to round to decimal that we would then take that additional step. Now with our square root property, so step 1 says variable on one side, or quantity square on one side, variable on the other. And we can see that I have variable on one side. Sorry, I keep saying variable, that's not what I mean. Constant on one side, quantity square on the other. And so in this case, I have the constant on the left, the variable square on the right. We can work it that way if it's given that way. We can also use our symmetric property of equality if we want to rewrite it and we just flip sides. Whatever's on the left side goes to the right, whatever's on the right side goes to the left. In either case, though, our first step is to insert the square root, and on the side that has the number, we insert the plus minus symbol. So in either case, now if you notice on the where the x squared was on the left-hand side, that I did have to be careful so that I left myself enough room to put that plus minus in. One of the problems whenever we write this is we're so used to putting the number immediately after the equal sign that when we go to put in the square root, we're having to cram it in there, and then there's not any room to put the plus minus symbol, or y'all end up doing something like that, and then I can't read it. I don't know what it means. So you do want to make sure that you are leaving yourself ample space as you work these problems. So simplify, we have our plus minus. Square root of 64 is an integer. It does simplify to 8. The square root undoes my square, leaving me just my root. Once I've applied the radical, it's done. So the square root of 64 giving me just 8, it's done. And of course, we then have those two solutions. If I did ask for set notation, sorry, I just hit the calculator. I didn't actually want it open yet, but anyway. Set notation with our braces, we can list the numbers, 8 and -8. And since we are listing the numbers, order does not matter. You could put -8 first and then +8. Makes no difference at all. And then, of course, if we worked it the other direction, we'd have the x plus minus, and then we have our 8. Now, our next one, we can actually work two different ways. In particular, this one is designed this way. But our first step says isolate the quantity square. So definitely we need to subtract 25 from both sides. And of course, I don't need to see the subtracting step. Now, 36 is a square, but the left side is not written as a quantity square. So given that that's the case, if we're following the steps very strictly, then our next step would be to, or we're still as part of step 1, sorry, isolating so that we have our y squared equal to, and notice I'm going to leave myself some space here before I go in now to take my square root. So quantity square on one side, only numbers on the other, plus minus in front. I get y, square root of y squared gives me y, plus or minus. We know the negative comes out as an I. Square root of 25 is 5. Square root of 36 is 6. And one thing that doesn't quite look right about the way I wrote it, that I is neutrally to the side or with the numerator. If I write it too low, it looks like I have it with a 6, which would not be correct. So that is strictly following my steps. If I worked it, one of my other options would be to say that I recognize that the right side can be written as a quantity square because 36 is 6 square and y being the y square. So I could do that as an option. I could also, because 36 is a perfect square, we could just take the square root of both sides, but that only, both of those are only true because of that being a perfect square. And so again, now again, here's a case where I did not leave enough room for my radical and my plus minus symbol. So here, because I wrote it as a quantity square, square root undoes my square, leaving me the 6y. Square root of 25 is 5, square root of negative 1 is I. And then that solving step would mean dividing both sides by 6. So same answer, just two different options on how to get there. Now, my little note over here to the side. So this is where I want to start emphasizing. This problem has just a y square. It doesn't have a single y. Same thing with question 1. It just has an x square. It doesn't have a single x. So when we talk about isolating the quantity square, in both of these, it is just the variable square. There's not a variable to the first power in either of those. That's very, very important for where we're going. Now, in question 3, and again, because I specifically want you using the square root property to solve this one, then the first thing we want to note is there is a quantity square in this problem. So I do not want you to expand it. That's not what we're looking for here. Step 1 says isolate the quantity square. So since we do have a quantity square, we want to move that 20. So we're going to add 20 to both sides. And notice when I did that, I left myself some space. And of course, if you want to show the plus 20 on both sides, absolutely continue to do so. Now I'm ready, since I've isolated my quantity square, and so that those parentheses are that key thing that we're talking about here, because everything that's being squared is inside those parentheses. That's what makes it a quantity square. I'm able to do my square root property. So square root of the left, because it's a quantity square, square root of the right. The square root undoes my square. It leaves me just the 4w minus 14. And I did forget to put in my plus minus. Let's go ahead and add that in. We're going to use our calculator and simplify the square root of 20. We learned how to do it in the last chapter to do it ourselves. That gave us 2 on the square root of 5. And of course, just as a reminder, that's because that was 4 times 5, and the square root of 4 is 2. Now, we're at the step 3, solve. We want to get the w by itself. I'm going to add 14 to both sides. Now, because this plus minus says I have plus 2 on the square root of 5 and minus 2 on the square root of 5, I do have to make sure that I'm keeping that those two things separated. I can't add them together right now or subtract them from each other. And my preference is always, whenever I bring that term over, that I put it in front of the plus minus. And I'll show you in a second why. Of course, next step, divide both sides by 4. And again, going back to prior knowledge, we do need to simplify this. And when we look at this, we can see that 14, 2, and 4 all have 2 in common. So I can do it one of two ways. I can factor it out. And then I can simplify. So that I have that final answer, 7 plus or minus the square root of 5, all over 2. I could also have split it into 2 and simplified each fraction. So plus minus. So I can set it up either way, just knowing I have to finish simplifying that one. Now, I was mentioning, and of course, if you put it into the calculator to double check your simplifying, you can only put the plus or the minus in. You can't do both at the same time. Our calculator doesn't have a plus minus key. And again, the calculator is going to switch the order. But what I find sometimes that people have difficulty with is getting the answer right if they wrote it this way instead. Because one of the things that happens as we're trying to work that, because I always write it in the order that I gave you up here, and so because you're used to seeing it written one way, but if you write it a different way, what happens is, sorry, that's the 14. What happens is the plus minus gets moved around because you're used to seeing it the way that I write it in the middle, and so then you change up the whole problem. So that's one of the reasons I don't like it. Um, and if this 2 on the square root of 5 was an integer, we tend to get confused on how to do plus the plus version plus the 14 and the minus version with it. So just be aware of, if you change up the order of things, that you're being extra careful of those nuances. All right, now in 4A, this is a precursor to the things we're going to do on the next page, because one of the things we have to be very, very careful of is when is it okay to round? And generally what we're trying to do is wait to the very last step. So we have to think in terms of, if there's a fraction in our problem that is a non-terminating decimal, our impulse is to do that and round and use that value, but you've now introduced what's called a rounding error. So you would actually leave it in fraction form. But this little demonstration here is to help us actually on the next page, because we're going to end up with this number in our problem, and one version of the answer just started pouring down rain, so of course my dogs decided to go bark at the rain. Anyway, we want to compare these two versions of our answers. If we take -1 and we have plus the square root of 1.859, oops, let's try that again, 59, that's going to give me 0.3634, and we're just going to truncate it, 3634. And then when we do our other choice, we have -1 plus the square root of 1.9. That gives us 0.3784. And when we round those two, and so again, looking at those two, we can see, depending on what place value I round to, would give me potentially the same answer or totally different answers. If I told you to round to the nearest tenth, we would have the same final answer, 0.4. But if I round to the nearest hundredths or thousandths both of those come up with different answers. So it's really important that we are not rounding until our very last step anytime multiplication or division are involved as part of my process. And square root is a process of multiplication, because you're undoing the product of two values. So that falls into that category. Now, one of those things I was talking about back up with this warning up here is in the lesson we're getting ready, or the part of the lesson we're getting ready to get to, we're going to end up with something like this written on one side of our problem. And the thing that we can't do, I already restarted this lesson from scratch once because my dog's barking. I'm trying not to have to do that again. So I apologize for the disjointedness of this part of the conversation. The temptation in where we're headed to on the next page is that once we get the terms that have variables in them isolated as the first part of that process, is that we want to try to split them into two separate ones and work from there, especially one like this, where there's a number in the problem that is a perfect square. This cannot be done. You absolutely cannot split up a radical over addition or subtraction. So knowing this, we have to know this in order to, and we have to practice our complete the square process in order to be able to get through all those steps correctly. So just a precursor of where we're headed. All right. Now for this one, we want to round our final answer to the nearest hundredths and to the nearest tenths. And again, here's a reminder when dividing, wait, sorry, different reminder. So if when we divide, it doesn't turn out to be a terminating decimal, then reminding you again not to round and that you might need to leave it in fraction form. In this particular one, we're not going to have to leave it in fraction form because it is going to divide evenly and terminate, but just as a reminder. Okay, so our first step says isolate the quantity square. And so notice parentheses and that square. So isolating the quantity square, the temptation, especially for the problem that has a number in front of the parentheses, is we tend to think, oh, I should distribute. But that quantity square is the higher order concept right there. And that says that those two things don't go together. That I can, however, isolate that set of parentheses by dividing both sides by 1,000. Now, 1,000 goes evenly into 1,859 and gives me 1.859. So that was the number we had on the previous page. So we've isolated our quantity square. Our next step says let's take the square root of both sides. And on the side that has the number, we put our plus minus. Now we could in fact put the plus minus on the side that has the variable, but that does add extra steps. And so we don't really want to add extra steps. Now, because we've already seen that the square root of 1.859 is a non-terminating decimal. So this is where I'm talking about for this in this kind of problem where we don't want to simplify the 1.859 right now. We just want to leave it under the radical for the time being. And we also didn't want to round it to 1.9. Square root undoes my square, leaves me 1 plus r. Subtract my 1 from both sides. So I have -1 plus or minus the square root of 1.859. So that's my answer for r. And since I asked around the final answer, we're going to go ahead and split it into our two possibilities. -1 plus the square root of 1.859 and -1 minus. Now we did not work both of these cases on the other page. We just worked one of them. And so the plus gave us 0.3634. So if I round that to the nearest hundredths, tenths, hundredths, thousandths, 3 tells the 6, to stay the same. And if I asked you to round to the nearest tenths, we'd go back to the original, and the 6 tells the 3 to go up. You never round and then round again. All right, let's do the other one. -1 minus, oops, sorry, I didn't get out of that screen. -1 minus square root of 1.859. And that gave us -2.3634. And then again to the nearest hundredths, -2.36, and the nearest hundredths, -2.4. So we're by keeping it in radical form until I'm ready to get the answer and rounding only in that last step, I'm given the most accurate answer. Now, when we take a look at this next word problem, this particular word problem is a special case of compounding annually. Because normally we have compounding and it could be annually, it could be semi-annually, it could be quarterly, it could be daily, it could be any one of those variations. And when we have that, there is a difference to this formula. But whenever we do the annually, we're using a modified version because we want to talk about square root property in particular. Now, generally what I find is, one, the phrase interest rate versus, if I just say rate, interest rate and rate mean the same thing. When we use the simple interest rate, I find that interest rate and rate can be confusing as far as where does the amount of interest versus the rate of interest. That those two things meaning different have different concepts, but that phrasing sometimes is confusing. In our compound question, we have a different variable we're working with. We have A, and the A stands for the total amount that's in the account. So it's the principal that's in there plus it's any interest that you earned. So that the puppy just brought me a toy to play with. That's what the squeaking is, that you can hear it across the microphone. So the total amount in your account is what's in there after the compounding happens. And this could be either interest that you're earning on something, or it could be the amount of interest that you have to pay back on a loan. So but it's always talking about a total. Versus P is your principal. That's the initial amount that's in your account. So that P, that's the initial amount that's in your account, your principal. So the amount that you're borrowing or the amount that you're investing. And then when we go back to find A, that has that same amount that you borrowed or invested, but then it also adds the money you earned or the money you have to pay back because of making the loan. And so in addition to the loan. Rate is a percent. So if you have to, it's given as a percent, so we have to convert it to decimal, which means we always divide by 100. And if we're trying to find the rate, then when we find it, it's going to be a decimal, and we have to convert it to percent by multiplying by 100. So that's that hidden extra step that's involved with that one. Time is always in years. And if I give you any other unit other than years, you do have to convert it into years before you can use it. Now, this is math land. I'm only doing years. We're not focusing on that here. Your steps with this type of a word problem, you have to be able to identify the values that we've been given. You have to be able to substitute them into the formula. And then you need to be able to simplify that given formula. Now, if we go back up to 4b, then that's actually what we just did. So for this particular problem up here, the amount that was in the account after the compounding was the $1,859. The amount that we initially invested was the $1,000. The rate is what we're trying to find, and the time was a 2-year investment. Okay, and so when we came up with that decimal up here, we had the positive and the negative. Obviously, we don't have, well, if we've made money or we have to pay money back, there's not a negative interest rate. If we lost money, then there definitely would be a negative interest rate. But in this case, we made money, or we owe money back. I'm not sure which one this was. Let's see. Um, so the amount, this was an investment. Now, one of the things about percents with investments is that we do want to do this multiplication before we round, which is one of the reasons that I gave you so many decimal places here. So we multiply this by 100, that's going to give us 36.34%. And then this is what I would round. So if I ask you, I could ask you to the ones, the tenths, or the hundredths, and it just depends. So if I asked you to round to the tenths place, this would be 36.3%, versus if we had rounded and then gone to 100, we would have just had 36, or if we had rounded to the tenths place and then gone to percent, we would have said it was 40%. So nuances of the problem do make a difference. Okay, now complete the square. There's literally in your homework a question you have to answer true that says, I understand that I have got to solve these problems by complete and square, and still people will do them by a different method. You choose a different method, that's totally up to you. However, I am only grading complete and square, so that's what I want to see. If you choose some other method, even though you get the right answer, that's not helping any with me assessing this particular method. So please, 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 I don't care if you look at help me solve this and it does a different method. That's not what I asked you to do. I don't care if you use an app and the app does a different method. You need to use the method I asked for. So when we want to complete the square, our overall objective is that we want to get one side of my problem to be a perfect square trinomial. Sorry about that. And once we have it written as a perfect square trinomial, we know that perfect square trinomials factor as square binomials. So when we're able to make that happen, then we're just going to follow the same thing that we did on the other page. So we've just got that one part of the process that says, how do we create a perfect square trinomial? Refresh our memory, how do we factor that? And then use that square root property. So it's really not that difficult. And you know, part of the beauty of this is once we've learned these methods, we get to pick and choose which method we think is easier, because definitely there are some problems that I would not complete the square. It is not the easiest choice. But then there are others that it's like, wow, this is much faster than having to do all the calculations with the square root, or sorry, the quadratic formula, because that requires me to have a calculator to get that final solution. Just because I need it usually to do the work underneath the radical. So, so our process. One, we do this got extra compared to just our square root property, but we're going to bring in our square root property questions here. So these steps, 4, 5, and 6, we've already done. Step 1, we want to have any term, all terms that have variables on preferably the left side, and then that implies that we want constants on the right. Now, once that's done, the coefficient of the x squared has to be 1. If it is, like question 6, we can go on to our next step. If it's not, like question 3, then we have to divide everything on the left side and everything on the right side by that coefficient. Um, if we've already moved things around, well, it doesn't matter. We have to divide everything on the left side and everything on the right side by that 3. So we'll look at that when we get there. So step 1 is already done for me. Step 2 doesn't need to be done. We're ready to do step 3. So whenever I'm ready to do step 3, one of the things that I do is rewrite my problem. And I put in a space on the left side, and I put on that same space on the right side. Because what we do to one side, we do to the other. And then the other thing that I want, and hold on, I'm going to pause a second. I'm going to rewrite that and just make my space a little. All right, so I rewrote it, add the same thing on both sides. Now, this is where we have to come up with that number that makes the left side a perfect square trinomial. And whatever I add to the left side, I'm also going to add to the right side. Now, I call this finding the magic number. What we're doing is creating that perfect square trinomial. And that's what the pre-notes were about. So if you've not watched that, I would go back in and watch that first. Because our step says we're always going to take the b value. We're always going to take half of it. Because perfect square trinomial, outer and inner, are always the same thing. There's always 2 of them. And we're always going to square it. And I always do this to the side. I simplify. That's going to be helpful to me in a minute. And that resulting value, which in this case is 9. So when I add it on the left side, that side's now a perfect square trinomial. Added on the right side, I've kept my equation balanced. So complete the square on the left side, and what that means is add that new term to both sides of the equation, and that creates that perfect square trinomial on the left. So that we now want to write the resulting binomial square. And the reason that I like to do this step is because whatever I have written over here, the sign, which in this case is positive, and the number also magically create that factored answer. So I don't have to do AC method, I don't have to do trial and error, I don't have to do anything. That's the relationship that I've created. Simplify the right side. Now, the problem that we resulted with, that looks like what we just did in question 3. So, see, simplify the right side. Here we're step 4. Step 5, we're now ready to, and I'm going to do step 5 separately. Every other time we do it, I'm going to do it in the same step. But I'm going to recopy this step just so I can make sure we're seeing the steps as their individual pieces. So again, notice I left that space over on that side. Square root property, plus or minus. So I applied my square root property and solve. So we've got x plus 3 equals plus or minus the square root of 2. Subtract that 3 from both sides. And that represents my 2 exact answers. Now I could ask for 2 answers rounded to decimal. I could ask for 2 answers as x-intercepts. I could ask them for x-intercepts with the exact value or for the rounded value. So lots of different ways I can ask. We'll look at the x-intercepts on the next page. But let's look at our steps here. Variable terms on one side, constant on the right. So I'm going to subtract 6 from both sides. If the coefficient of x squared is not 1, divide both sides of the equation by the coefficient. This is not a 1, so I'm going to divide this by 3, this by 3, and this by 3. Now, you could have done the division step first and then moved the term. Doesn't make any difference. What does make a difference is the fact that everything gets divided, even if you did it from this step, because you've got to show me that what you do to one side you do to the other. Okay. I swear there was something else I was going to say as far as dividing, moving. I don't know. I think I was just trying to say that if you divided first and then moved, you'd end up with the exact same thing. All right, so we've done step 2. So this was step 1, and then this gave us step 2. Complete the square. So my magic number, I take the coefficient of the x term. I'm always taking half of it. I'm always squaring it. I always write it, the simplified part, in parentheses. I want to know what that number is before I get my magic number. Magic number gets added to both sides. I've kept my equation balanced. So now I'm able to turn this trinomial into a binomial square. And the second step of my magic number, there's my operation, there's my number. We could, of course, also, whatever my operation is, if it's subtraction here, and over here, when it was addition here, it's addition here. Simplify gives me 23. Notice I left some space. Apply our square root property. So let's see. We did step 3 here, and we did step 4 to get here. And then this is where I was talking about over here, I did step 5 of it as its own step. But if you want to come in, now that you've got it written, and do step 5 there, that's perfectly fine. But you've got to know that those two steps are combined. If you're just trying to model this, I think sometimes that gets very confusing if you're not clear on where 4 and then 5 came from. All right, and then square root undoes my square. So we have our x minus 5 equals plus or minus square root of 23. Add my 5 to both sides. And in both of these, we had real numbers that weren't perfect squares. So we had those two irrational solutions. And if we had done discriminant, which is we know is our b squared minus 4ac, that would have told us we were going to have irrational answers. We were going to have radicals in those answers. All right. Now, a little bit of general information, and this will help with the vocabulary on your vocabulary assignment and your upcoming vocabulary quiz. So as a reminder, general or standard form of a quadratic function has f of x, and we know it's ax squared plus bx plus c, where a can't be 0. And we know that when we graph it, that shape is a parabola. Graphs can either open up or down, and they either don't cross the x-axis, they have one repeated answers, that means the vertex sits on the x-axis, so it has one intercept, or it crosses the x-axis twice for 2 intercepts. When we're solving quadratic equation for x, if we wanted to graph it, then that solving for x also gives us the x-intercepts. That's that relationship between those two answers. How are they used algebraically? How are they used graphically? And when I ask you for x-intercepts, they are always written as ordered pairs. And so we know that when we're looking for the x-intercept, the other thing we know is that the y value of that ordered pair is always 0. So that's how we are able to do the step, and we're going to see that here in just a second. So another complete the square question, and we want to find the x-intercepts of the function. So notice this one is given to us in function notation, whereas the others weren't. So directions are implying to solve. I'm telling you specifically I want you to complete the square, and I'm telling you the format of your answers. So what we have to know is that what I mentioned up here, that our y is 0, and which means in this case that my function f of x is equal to 0. So that says our first step is, let's rewrite this as 0 equal. Now we notice in this one that the equation has the equal 0 on the left side. So the first thing that I would do is just use my symmetric property of equality and write it the other way. And I'm just abbreviating that. Trying to save time, and now I scribbled. Symmetric, SYMM is how I'm abbreviating that. So my symmetric property equality said I could just flip-flop those two sides. And that just because that way I'm following that consistent look of my problem. Step 1 says get my x values or my variable values on one side and my constant on the other. So we'd add 5 to both sides. Second step says if my lead coefficient is not a 1, I have to divide. Since it is a 1, I don't have to. Third step says create the perfect square trinomial. I'm going to take the coefficient of the b term. We're always dividing it by 2. We're always squaring it, which gives me -1 squared, or 1. So if I add 1 to both sides, on the left side, that creates a perfect square trinomial, which then factors as the square of a binomial. And the right side simplifies to give me 6. Apply my square root property now. Put in my plus minus. Do my solving steps, which in this case just says I have to add my 1 to both sides. Ooh, I almost deleted that whole thing. Sorry, I'm not sure where I hit the pause or the stop button. So added 1 to both sides. This is like the answers I got on the other page, but because here I asked you for x-intercepts, my exact answer would be 1 plus the square root of 6, comma 0, and 1 minus the square root of 6. Well, that doesn't look very good. Comma 0. Those would be the exact answers, and I believe that's what my math lab is looking for. Now, if we wanted to graph it, graphing 1 plus the square root of 6, I don't know exactly where that is. So I would definitely convert to decimal if that was the case. And we'd have to hit our back and forth key to get our decimal. And I believe, let's see, approximately 3 decimal places. All right, 3.449. Comma 0. And then our conjugate 1 minus the square root of 6. Oh, that's not right. And again, that's why I always look at the screen as I'm doing this. And back and forth key, negative 1.449. Now, realistically, if I was going to graph those, I would have told you to round them to the nearest tenth. Rounding them to the nearest third decimal place really isn't very useful because we're not going to graph to 3 decimal places. But anyway, since that's what I asked for, obviously I wanted to make sure we could go to 3 decimal places. And this is a good place just to remind you, if I just said 3 places and I didn't have the word decimal in there, that decimal is implied. When we say places, that does imply we're talking about places after the decimal point. So just as an FYI. Now, last thing is I pulled this directly from, they helped me solve this in my math lab. So for those of you that are using it to help you prompt you with your steps, again, I'm going to remind you, if you do all your assignments just by following Help Me Solve This, that you're not internalizing the process. So you really need to be, if you use it once, then you need to go back and do another problem on your own. Make sure you can follow all the process. But ideally, you're looking at the steps that I gave you, rewrite them if you need to, rewrite them in different phrasing, add more, take away, whatever. But you really have got to be figuring out and following those steps on your own to be successful with being able to do this on a test. But anyway, my math lab. One, notice the definition that we talked about, that they provide that definition again. So if you're looking at that, you don't need to put that in your notes. That's already in your homework. That's already in your definition. Now you can see they started following our steps. They isolated the square term. They did that. Now the next thing in my math lab, they go from this step to this step. And they are not demonstrating the square root property. They're not demonstrating how you got from one step to the other. That's the specific thing that I'm asking for, because that's what we're really emphasizing. What is the square root property? What happens, so that those of you going on to pre-calculus, y'all get to skip that step in pre-calculus because you're going to be able to go from one to the next. But if you skip that for me, that's when I'm going to write step, and I'm going to take off points because I specifically told y'all that's what I want to see. Now they did do the work to split up and bring the negative out separately. There, we've already done that on a previous test. We've already practiced that. I don't necessarily need to see you do that step. If you do, great, but you don't have to. And then of course, just putting in the 81 over 121, the calculator. Now notice this is the exact answer. And even with the I in it, I would still want the 9/11. There's not anything here that implies that I want you to convert that to decimal. It would be a non-terminating decimal. And with I, we almost never give that rounded answer with the I. We usually being more precise with that. And then of course my math lab, they already give us this case the variable x equal 2, so you're just putting the number in. If you are putting in 2 separate answers, you've got to make sure you're using the comma to separate the answers. Oh, and I'll go back up to the other one and talk about that again real quick. But we do have the plus minus key. And so when you can give me a combined answer, you can use that plus minus. Here. When you put either of these two into my math lab, those directions said separate with a comma. If you don't put that comma in there, it will mark it wrong. So do make sure you're watching out for that. Okay, that takes care of our square root property and our completeness square property.